those questions which you had already sent me,
Yes.
you could have sent more. Right now, you can send more questions
Okay.
if you have them with you.
All right.
Okay. First of all, let me explain. Later we will see if we can send more number of questions, then we'll try to solve them all, right? Okay.
Okay.
Please. Some techniques, some more techniques, right?
All
More
right.
techniques and examples, right?
Yes.
Okay, number one. You see, let me take this pulley. I will be a little faster today because you have already learned many things,
Yes.
and it is mass. It is also a mass here. This moves up with 10 meter per second. Can you tell me what is its velocity? It is.
Also,
It is fixed. It is fixed. What is its velocity?
10 meters per second downwards.
Good. Nice. Okay. Second. Is it difficult?
No.
No, so easy. Okay. This is a pulley. It goes up with 15 meters per second. And this is an object. It goes up with 5 meters per second. Please tell me what is the velocity of this object? What should be the velocity of this object? Upwards, downwards, what way?
25.
Upwards?
It will go upwards at 25 meters per second.
So good, so nice, so nice. Suppose it goes with velocity v, right?
Yes.
Let me suppose. So what should you write? 15 is equal to 5 plus v by 2.
Right.
This velocity is sum of these two velocities by 2, right?
Yes.
5 plus v is equal to 30. Multiplying this to this, right?
Yes.
V is equal to 25. So you are wise enough to say directly it's 25.
Right.
Oh, good. So nice. Third, it is a pulley. It's going up with velocity v. It is object. It's going up with 50 meters per second. And it is an object. It is going up with 10. What is this velocity? What should this pulley go up with? With what velocity this pulley should go up? 50.
7.5.
Plus 10 by 2, that is 60 by 2, that is 30.
Yes.
Up or down?
Up.
Good. I'm showing things, possibly you already know, but I'm showing things again and again, so that these things become the part of your mind, so that you will answer questions directly without any problem.
Right.
Okay. Fifth or fourth.
Fourth.
This is a pulley, goes up. The same object. It goes with 50 up. It goes with this object. It goes with 30 down. What is the velocity of this point? Up or down?
It will be up.
Good. Because this upgoing velocity of this mass is more. It will be 50. Yes.
Minus over 2.
That is so nice. That is 20 by 2. That is 10 meter per second. Up or down?
Up.
Good. Very nice. I think you have given it a good time. Fifth. Okay?
Okay.
That's good. That's nice. Now, okay. Now let's go to the different class of problems. See here.
Right.
It is pulley A. It is object B. It goes downward with 10 meters per second. Do you look at this?
Yes.
Okay. My question is, what is the velocity of pulley A? Pulley A. Can you think for a moment? It is fixed here.
Yes.
Can you think for a moment? What is the velocity of this pulley A? Pulley A velocity is the same as this point velocity, right?
Right.
Can you tell me that?
10. Still 10 meters per second.
Do you
As
think
this,
it is?
oh,
Is it 10?
I think so.
Okay, not bad. Is it 10?
Because this one, it's the same string attached from the mass.
Listen to me. It is 10?
Yes.
What is this velocity down?
10.
Okay. What is this velocity? This point velocity?
10 up.
That's very nice. 10 up, it's 10 down. This point is directly connected to this point through a pulley which is fixed. Therefore, this point and this point must have the same velocity, right?
Right.
Now, you can't say this. You see, Fatima, this point and this point need not have same velocity because they are not connected directly through a system which is fixed. This pulley is not fixed. So you can't say this point and this point have the same velocity.
Yes.
Now you understand the concept.
Yes.
This and this have the same velocity because they are directly connected through a pulley which is fixed. But this point and this point are connected directly, but not through a pulley which is fixed. It is not fixed.
Right.
What is the velocity of this point? Shabash.
Velocity.
Should I tell you and then you will remember all the time?
Yes.
It is big zero because it is fixed to this. It is connected to the fixed point. It is velocity zero. It is velocity zero. It is velocity zero because this string is connected to the fixed platform or fixed ceiling. Now, what is the velocity of this point? 0 plus 10 by 2.
Right.
This plus this by 2. That is 5 meters per second up.
Yes.
Now you understand?
Yes.
Should you copy this question?
I did.
Okay. Copy this.
Okay. Okay.
Done?
Yes.
Okay. Accelerations follow the same rules as velocities.
Yes.
Follow the
same rules as velocity.
Okay. Now let me go to one more. Number 6.
Yes.
The acceleration of this mass is A.
Yes.
The acceleration of this mass is A, right?
Yes.
What is the acceleration of this object and in which direction? A prime. Can you think for a moment?
Yes.
Okay, just think for a moment. You have every right to think about.
Okay. Acceleration prime is in the upwards direction.
Maybe yes. Should I solve it for you?
Okay, I'm still working on it.
Okay. It is good to think for a moment, and so that when I solve, you understand that. It is the acceleration point. This point has acceleration down. A.
Yes.
It is 0
Yes.
because it is fixed to this. It is here fixed, right? When I say it like this, it is fixed. These are fixed points.
Oh, okay.
So what is the acceleration of this point? Down.
Downwards.
It is A. It is 0. A by 2.
Yes.
Because it is A plus 0 by 2, right?
Yes.
It is A by 2. It is 0. So what is the acceleration of this point?
A by 4.
Good. Very nice. What is the acceleration of this point?
A by 8.
That's very nice. And what is A dash equal to? This point and this point has the same acceleration. Why? Fixed. They are connected through a pulley which is fixed.
Yes.
That is the answer.
Oh.
You understand that?
Yes.
Okay.
So when the box, like for the masses, when the masses are not shaded in, that means acceleration is 0. And when it's shaded in, that means it's the acceleration is not 0 for notation.
That's right.
Oh.
That's right. Okay. Now, one more question.
Yes.
This pulley moves forward with a velocity of 30 meters per second. This moves with 70 meters per second. What's the velocity of this block forward?
This block forward is 50 meters per second.
How do you know? You add these.
Yes.
You add these and you get the answer, right?
Yes.
I don't know. Possibly, maybe this is the right answer, but honestly speaking, I don't know.
Oh. I took the average of the two velocities.
You just added, possibly then divide by 2, right?
Yes.
Okay, let me see. If that's the answer, then I have learned a new method from you.
Oh.
Honestly.
Oh, no.
Honestly. What is the velocity of this? V? That we have to find?
Yeah.
What is the velocity of this point?
Velocity of this point.
V.
Oh,
Velocity of this point?
V.
V, good. Because these points are directly connected to the block. So if this block is moving with V, this point is also moving with V, this point is also moving with V, right? Is that right?
Yes.
You see this block?
Yes.
If this block, we say that it moves with V, why can't we say this point also moves with V and this point also moves with V, right?
Yes.
So this point has also velocity V. What about this point?
That point. 30.
It is 30. It is V forward.
Right. And that is V.
30
back.
is equal to V plus V prime, that you say it's V prime, right?
Yes. Over 2.
By 2. So what's V prime?
So
60
V
minus V.
equals V prime. Yes.
60 minus V. Okay. Now, this is 0 because this is fixed. What is this point? What is the velocity of this point?
Velocity is
Forward. This
Yes.
is 70. 70 is 0 plus this by 2.
Yes.
So
And
this
then
must be 140.
yes.
Because this 70 is equal to 1, something like whatever, v double prime plus 0 by 2. V double prime is 140.
Yes.
Okay, now what is this v? This v is equal to, okay, v prime plus
140
v prime divided by
2.
That's good. This velocity is sum of these two velocities by 2. It is 2v is equal to v prime plus 140. We have to find v, right? That is this v. This v we have to find. 2v is equal to what's v prime? 60 minus v,
Minus
140. Look at this. V prime. It is v goes to this side is 3v is equal to 140 plus 60. What is that?
200.
Sure. V is equal to 200 by 3. Your prediction was wrong.
Yes.
It will not work that way. No?
Yeah, no shortcuts.
No shortcuts, yes. So do you understand what I have done?
Yes, you drew in the vectors and then solved.
Okay, should I show you one more method?
Sure.
Will you? I don't think you will appreciate that method.
Is it with work formula?
Yes?
Oh, I think I can see. I want to see.
You have copied this.
Yes.
Do you remember the answer? 200 by 3, you remember?
Yes.
Okay. That's good. That's nice. Okay. Let me rub it, huh?
Okay.
Have you copied?
Yes.
Okay. Let me rub, let me see how the other method works.
Okay.
Okay. Oh, sorry. I want to rub certain things now. Chalo, okay. Tension is T?
Yes.
Here?
T.
Good. Here?
T.
Here?
T.
Here?
T.
Here?
2T.
Very nice, Fatima. You are really intelligent. Here?
T.
Here?
T.
Good. Okay. How many tensions acts on this V?
On this velocity.
T and 2T. How many T's?
3 T's.
Into this velocity.
3 T times velocity. Okay.
Is equal to. It is 30. On
Right.
how many T's it acts?
2.
70. On how many T's it acts?
2.
Okay. It is T and T cancels. It is 3T is equal to 60 plus 140. That is 200. T is equal to V, sorry. It's V T cancels. V is equal to 200 by 3. Answer.
Yes.
You can remember this.
Yes.
Should I show you one more question on this technique?
Yes. For tension.
You know why from this technique comes?
Tension times velocity.
Huh.
No.
Basically, it is work done by all the internal forces is 0, or the power developed by internal forces is 0.
Okay.
Force into velocity is power, if you remember, Fv.
F equals power. Okay.
If you know work done is equal to F dot S.
Yes.
If you differentiate dW by dt, that is F dot ds by dt, and this is power. This is F dot V.
Over.
No, you don't know.
Okay.
Chalo jane do, chodo. Because for that you need to know work, power, energy.
Okay.
You have done that.
Not yet. That's the next chapter.
Okay, you will do that very successfully because that's easy. Easier than
By
this.
next class. Yes.
Okay. Should I show you one more question on this?
Sure. Yes. This way.
Okay. This is a block. And this is one more block. This is pulley, and this is here, fixed here. And this is pulley. This is pulley. This is pulley. This is pulley. How many is on this side? Yes. This is pulley. This is pulley. On this side, 4, yes. On this side, 3. Now, this is connected like this. 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 This is connected. Right?
Yes.
This moves forward with 100 meters per second. What's the velocity of this block? Mistakenly, you feel that this V is also 100 because you feel that they will move together. No, these strings will shrink and they will stretch and shrink, and this will have different velocity than this.
Yes.
Now the question is, what is the velocity of this, right? Now see, how much is the tension?
T.
T, yes. You start with string tension T. What is tension here?
T.
Okay. Here?
T.
Here?
T.
Same string, right? Same string has same tension. If you remember my lecture.
Yes.
I don't know, do American teachers say the same thing? I don't know.
Oh no, same so far.
They must. No? Okay. And tension T and tension T here. Right?
Yes.
Will you tell me how much tension is here?
2T.
Good. Because force across the pulley should be 0.
Right.
2T and 2T. 2T. 2T and 2T. Right?
Yes.
Here?
2T.
Here?
2T.
Here?
2T.
Here?
Just T.
Just T, yes, that is right. Now see, look at this so carefully. If I ask you what is the tension on this pulley in this direction?
2T.
Yes.
2T. 2T.
Okay, don't bother about this now. Now see, how many tensions are acting on this?
2, 4, 8.
8, good. 8T into velocity. This is equal to how many T's? 2, 2, 4, 6, 7.
7.
No, 2, 2, 4, 2, 6, 7. 7
Times.
100. 70 into 100. ठीक? Okay? ठीक है इसका आंसर? V is equal to 700 by 8 answer.
Right. Perfect.
Is that right?
Yes.
If you ask me, I can solve each and every question by this technique. जो भी हमने आज इस वक्त तक दिखाया है.
जी. Perfect.
But we need not.
Right.
Let us not go into that now.
Okay.
Question number?
9.
Okay. Sorry, what happened? You are ready to give me the answer, right?
Oh, yes. Okay.
Sorry. What happens? Fixed, but it is pulley here, right? Fixed,
Yeah.
pulley here fixed. This has velocity 10 meter per second downwards, this block. What's the velocity of this? That's my question.
Okay.
Think for a while.
All right.
Now, I think I should go to your questions. What are your questions?
Okay.
Or should I show you 2 more questions?
We can finish, yes.
Can you tell me what's the velocity of this block going up or down? I don't know whether it should go up or down.
Which block? The big one?
Yes, this one. This one. This one.
Okay.
Okay, let me give you the hint. What's the velocity of this point?
Downwards? 10.
Okay. What's the velocity of this point?
10.
Good. Velocity of this point is 10. What's the velocity of this point?
So this one, it's fixed, so 0? Or no, wait.
Think for a moment. It is 10. This point and this point is connected through a pulley which is fixed. 10 up.
Yes.
I don't go into minus and plus. I go just if it's 10 down, this point should be 10 up, because you see, it is so obvious. If you go into mathematical negative positive, there one can commit errors.
Oh.
But here you don't need to commit any error. You see, 10 down here, this string goes down, and this has to go up.
Yes.
This is 10 down. Can you tell me what is the velocity of this point? Should it be
velocity 2.
Should be up or down?
Up.
Good. How much?
2.
Yes?
2.
2.
Yes.
It is
because
10. It is
10 down and...
It is 10 down, it is 10 up.
Yes. 20.
Yes. What should the velocity here? So that this plus this is equal to this by 2. This plus this by 2 is equal to this. This point and this point.
I think 2.
You mean 20 or 2?
2.
This one.
Yes, 2.
How? 2 is not any combination.
Oh, wait. My math is off.
Yes. This point is 10 up. This is point 10 down. What should be the point velocity here so that this plus this divided by 2 is 10 up? Good.
10.
Okay. It is 10 up.
Yes.
What is this? 10 down minus
10
10
down.
divided by
2.
that is 0. Is this point 0 velocity?
No.
So
Oh, 20. 20 minus 10 is, we subtract.
30
Okay.
minus 10 divided by 2, that is 10. First of all, it should be up. Why? Because it is down. This should be up so that the net is up.
Yes.
So it is 30 minus
10
divided by
divided by 2.
that will give you
10.
okay. It's 30 minus 10 divided by 2, that is 20 by 2, that is 10. If you consider this to be V, suppose, so you could have said, okay, V. So V minus 10 divided by 2 should be equal to what?
10.
Okay, so V minus 10 is equal to 20 and V is equal to 30 up.
Yes. Okay. Yes.
You could have done that way also.
Yeah, I was doing that. I had plus 10 instead.
Okay.
So I kept.
Yes, one gets into trouble in these equations and calculations. But your concept is clear, I think so. 30 up, what is the velocity of this point?
30 up.
This point?
It's fixed, so 30 to the left.
Answer.
Right.
That was our question.
Yes.
Should I show you, explain many more questions, or should I directly come to your questions now?
We can do my questions now.
Should I try your questions now, or should I show you more questions that I can have in my mind?
We can try my questions now too.
Okay, that's good. Well, now see here. Point is, you can send more questions on my WhatsApp so that I can show, but I have a few questions on WhatsApp so that I can show you those questions, right?
Okay.
It was which question? 9th. Okay. 10th one. This is one of your questions.
Okay.
I'm not good at making diagrams.
Oh, I understand.
Okay. These are the strings, and this is a block.
Okay.
The block has mass of 300 kg, right?
Okay.
With what force you have to pull it down, F, so that this block goes up? That is the mechanical advantage that you have. You just pull it down by a little force and this heavy block goes up. That is why what engineers are doing to these pulleys. They have a mechanical advantage. You just pull it slightly, it goes up. You cannot directly push this 300 kg block upwards, but if you pull it down by little force, this will go up. So we have to see how much force you need to exert downwards so that this block goes up. Do you understand the question?
Yes.
Okay, let's see. tension T, right?
Yes.
Here,
T.
good. Here,
T.
here,
T.
here,
T.
here, T.
Yes.
It pulls also with T, T, T. I'm showing force on these, right? I can show force on these also. If it's a string, there's a pulley here. This is one more pulley here. Tension is T here. Here it is down T.
Okay.
So every action is equal. You can show this. Now, what is this F equal to? T. Just T.
Yeah.
The force which you exert is just this tension T.
Yes.
Is that right?
Yes.
T, 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 and T, and T, and T. And this force, the force that you exert here, that is also T. Because along the same string, the force is same. This cannot be different than this T. How can these different forces can be through the same string? That is not possible. Right? Now see.
Yeah.
How much is here?
2T. 2T and 2T.
How much is downward force here? mg?
Mg.
300 into 10. That is 3000 Newton.
Great.
2 plus 2 plus 2. How many force are pulling up this?
60.
60 is equal to what? 300?
Yes.
What's T?
50.
500 Newton?
3000. Oh, yes, 500.
This T is this. So you have to exert only 500 Newton to pull up 3000 Newton. No. Do you understand that?
Yes.
You found T, but that is T is already F. You are exerting force F, but you are pulling how much?
300 kg. So 3000.
300 kg, 3000 Newton. A heavy force. By simply exerting a very less force, you are pulling this up. Do you understand this?
Yes. I see.
That is great. That is great. That is great.
That's a simpler method.
Simple?
The book explained it very weirdly.
I have seen the solution of your professors also.
Oh, yes.
They are very nice solutions, step-by-step solutions. I appreciate that.
Right.
Okay. So now one more, 11. This is like this. This is M, small m. This is capital M. M small is 5 kg. Capital M is 10 kg. You have to find acceleration of this down and acceleration of this up. Same acceleration, because this is fixed. This question I have already shown you.
Yes.
Should I show it again?
No, I understand.
You see, you have to find force. It's mg here, it's tension T here, it's mg here, it is tension T here, and if it is heavy, so acceleration is up, acceleration. So apply the force equation. Bad things on the left. Bad guys, I call these bad guys. Because you have to find them, you have to recognize these forces, and then you have to write the resultant. That's why I call them bad guys. So bad guy is this net, and good guy is here this. Bad guy, let me correct the bad guys. T minus mg.
T minus
ma, right? Bad guys, F net, these bad guys, T minus mg. Okay. Right. The bad guys here in this. mg minus
T
is equal to ma. Right?
Yes.
Now add mg minus mg is equal to a into m plus m. When I add them, this cancels off and this is getting like this. So acceleration is m minus m into g, this, Divide by
M plus M.
that is the answer. Now M is 10, 5. So 10 minus 5 by 10 plus 15 into 10. G10. That is 5 by 15 into 10. That's 50 by 15. That is 10 by 3. Answer.
Yes.
Isn't that right?
Yes.
Okay. This I had already shown you, but I'm showing it once again. But see, your teacher has done a good thing. He has separated them.
Yes.
You know what he did? See what he did.
Oh.
He made like this. And inside he said like this, and like this, and like this. And to other mass he did like this. Like this, like this, and like this. Wrote the equation here, wrote the equation here. He separated. He made it more lucid than what he made it more lucid than what I am doing.
Yes.
Okay. Then there was another question. That was something like this. 12th question, Shahid. Okay. Question was like, sorry. Is that right?
Yes.
Was this the question?
Yes.
They were connected like this, right?
Right.
And here, there's a string like this. This string goes like this, passes like this, goes like this, and then comes like this. This is F. You are exerting this F, right?
Right.
But there's a mass attached to this string downwards. Sorry. Mass attached to this. M. So how much tension you have to exert to lift up this mass? How much force you need to exert to lift up this mass? This gives you a mechanical advantage, right?
Yes.
It should not that you need to exert a force of mg. Mg is downwards. If I directly lift an object of mass m, how much force I have to exert in upward direction? You see, if this is a mass m, I want to hold it in my hand. How much force I need to exert in upward direction?
F normal. So
normal reaction. That is normal reaction is called mg. So I have to exert upward force of mg. Okay.
yes.
So if I directly lift an object with constant velocity upwards, or I want to hold an object on my hand or on my shoulder, I have to exert this much of force.
Right.
So it will be very hard for me, or it will be difficult for me to hold a heavy object. Now, but if I want to lift it up with constant velocity, by pulling this string downwards, how much force I need to create? Do you think mg?
No.
Shabash, no. I should have some advantage using this mechanism, using this mechanical device. I should have some advantage. So let me see. Tension T
Yes.
is equal to F, that you exert the force.
Yes.
Tension T.
Right.
Tension T.
Yes.
It is string says tension T.
Yes.
How much is the tension here?
2T.
Okay.
Right.
2T down, 2T up, same string here. Okay. If I want to lift it up with constant velocity, so 2T should be equal to mg, because constant velocity means no net force. If net force on this object is 0, that means 2T is equal to
mg.
If 2t is more than mg, then it will accelerate upwards.
Right.
So 2t is equal to mg. What about t? You need to exert only mg by 2 force, right? So you have an advantage here. If you pull, if it is 1000 kg, you have to exert only, if it is 1000 newton, you have to exert only 500 newton force to lift it up. Directly you have to exert the same as 1000 newton, but here you have an advantage. That's why we are using these devices.
Yes.
T and 2t and 2t, mg is equal to 2t, and you get t is equal to mg by 2. That t is you are exerting this force, right?
Yes.
Is that clear?
Yes.
Now you understand these things very clearly, and you can now have solve other questions also.
Yep. I think
Okay.
I got it.
Okay. That's great. That's great. Is it sufficient for today?
Sorry?
Is it sufficient for today? Should we stop the meeting now?
Yes, sure.
Okay.
Okay. Thank you. Thank you so much.
It's all right.
Okay, Allah Hafiz.
Allah Hafiz.